A warm welcome to one and all. It's my immense pleasure and privilege to be here with you all. And I'm your instructor for the webinar on the topic DevSecOps in Action, Essential Practices and Tools. Before diving into the topic, I would like to introduce myself. I'm Nithin Prince John, working as Associate DevOps Engineer at INAP. I'm a Microsoft Certified Trainer and IUC Certified Educator. And I have delivered 45 plus national and international workshops and trained over 2,800 professionals in the domain of AI. I was a team member of Leading India.ai project, which is the India's largest AI and deep learning skilling project, and also worked as a research sabbatical in NVIDIA Bennett Research Center on AI. I'm a recipient of IEEE Best Paper Award and Academic Excellence Award, and I'm having a consulting experience spanning more than 8 years in various domains. I'm very much passionate about learning, applying, and teaching cutting-edge technologies. That's a short intro about myself. This is the public notice regarding the usage of images in the upcoming slides, and these are considered to be covered by the doctrine of fair use. This is the agenda for today's webinar. As we know that today's topic is DevSecOps, but in order to know about DevSecOps, we need to have a clear understanding about what exactly DevOps is, and also the various tools used in DevOps. And the main backbone of DevOps is the CI/CD. So in this session, I am planning to start with what is CI/CD. Then we will go through the DevOps concepts and the various tools used in DevOps, followed by our main topic, that is DevSecOps and its various tools. And finally, we will be having a small demonstration of how we can utilize various DevSecOps tools in our pipelines. So let's start with CI/CD. So what do you mean by CI/CD? CI/CD actually refers to a method that helps us to frequently deliver the application to the customers by introducing automation into the picture. So in CI/CD, CI means it's the continuous integration, and CD refers to continuous delivery or continuous deployment. You may be thinking about what exactly continuous integration means, and also what is the difference between continuous delivery and versus continuous deployment. We will be clarifying all those things in this webinar. So basically, the main goal of CI/CD is to automate every bottlenecks that we are facing while releasing the software. So in normal software development lifecycle, we may be having several bottlenecks. So how to remove those bottlenecks or how to automate the entire things? So that can be done using CI/CD, or in other words, we can say that automation is the goal of CI/CD. CI/CD is referred to as the backbone of DevOps. Without CI/CD, we cannot do anything. Okay, so let me explain what is CI, that is the continuous integration. Let me give a scenario. Think like that I'm working in a team comprising of 10 members, and we are following Git as the version control system, and we are using feature-based branching strategy. That means whenever I need to create a feature, I need to create a new feature branch. Mainly, we will be having a main branch that contains the production ready code. So whenever I need to create a new feature, I'm going to create a new feature branch out of this main branch, and I'm going to do the work there. Once I complete that particular feature, in normal scenario, what happened is that we are going to raise a pull request so that other members in the group will review that, and if everything is okay, they are going to approve that pull request. And at that point, this code is going to be, the code in the feature branch is going to be merged in the main branch. So that is the normal scenario happening in every industry. But there is one problem. So let me tell you that problem. Think like that. In my developed feature, there is a bug. And if the person who is approving that pull request is is not carefully thinking about or is not carefully going through that code, without carefully going through that code, he is approving the pull request. And what happened is that at that point, the bug will result in the main branch, that is in the production ready branch. And from there onwards, it will create problems. So how we can resolve those issues? By introducing continuous integration, we can resolve that. That means whenever the developer is creating a new feature, they need to write the unit test. For every function that they are creating, they need to write the unit test. So what happened is, whenever we are raising a pull request, our pipeline will automatically take that code from our source control server, and we are going to compile or interpret the code. Then we will perform the unit testing in the continuous integration server. So if every test are passed, then only we will be able to approve that pull request. Otherwise, this pull request cannot be approved. So that means we are doing a particular type of testing in the pipeline itself. That means whenever we are raising a pull request, automatically the unit test will be happen there. And if any of the unit test is failed, the pull request cannot be approved. Thereby, we can make sure that whatever code that is going to be merged in the main branch will be a perfectly working code. So in this figure, you can see that whenever a developer checks in the changes to the source control server, at that time itself, we will be having a continuous integration server. This continuous integration server is going to fetch the changes and it is going to build the source code. This building means it can be compilation or interpretation. Okay. After that, we will perform the unit testing with what all test cases that we have wrote, and we are going to get the result. It can be a failure or it can be a succeeded one, right? And this notification will be sent to the developers. At that same time, if there is a failure, the developers can resolve those things. So by this way, we can ensure that every code in our main branch is perfectly working right. So this is the idea of continuous integration. Then what is the meaning of continuous delivery? You may be having different environments. For example, in various companies, they will follow different styles of architecture. In normal scenario, we will be having a development environment. Then we may be having a test environment. And finally, we may be having a production environment. So normally 3 environments will be there. So whenever a developer commits the source code, automatically this continuous integration comes into the picture. This continuous integration will build the source code. It will perform the unit testing. And if everything goes good, that will be merged to the main branch. And from that main branch, we are going to create an artifact. This artifact can be anything like Docker image. If it is a Java project, it can be a var or jar files. Okay, it will be depending upon the style of project that we are doing, right? Once we create the artifact, this artifact will be directly deployed to the dev environment, where the developers are going through the entire product, right? So if everything is working fine, then they will promote that changes into the test environment, which can be a QA environment or UAT environments. So up to this point, everything will be automated in continuous delivery. That means whenever the team commits the code, automatically up to the pre-production server, everything will be an automated working process. There will not be any manual process in between. So that is the idea behind the continuous delivery approach. When it comes to the, in the continuous delivery, thing like that, in the pre-production server, everything is perfectly working. At that time, we will give a green signal or we will give a manual approval. Okay, you can go with that. Then these changes will be directly promoted to the production server. Thereby, the entire product will be served from the production server. So that is the idea behind the continuous delivery. But when it comes to the case of continuous deployment, the things will change. By looking at this figure itself, you can see that here the manual approval is replaced by the automatic process. That means whenever the team commits the changes, from that point of time, everything will be going in an automated way up to the production server. That means this code will be tested, and if everything is okay, it will be merged to the main branch. Then we are going to take the artifact or build the artifact. This artifact will be directly deployed to the dev environment. There some testing will be performed, like the integration testing. Then if everything is okay, that will be promoted to the pre-production servers. It can be the UAT or QA or whatever it may be, right? It depends upon the organization. And if everything is okay in that particular UAT or QA environment, like what all tests that we are doing in UAT or QA, thing like that, we are performing the load testing or the performance testing. All these kind of things can be done in UAT or QA environment. And if everything that, if the test cases are perfectly right, then it will be automatically deployed to the production environment. So it's a complete automated approach. So this is referred to as the continuous deployment. Continuous delivery means we'll be having a manual approach at this UAT or QA stage, or in other words, we can say that there is a manual approach in the pre-production server, but in the continuous deployment, we will not be having that manual approach. Okay, everything will be automated. So this is the idea behind the continuous deployment. Then, what is DevOps? In short, we can say that it's a combination of two terms, development and operations. So basically, DevOps is a set of practices, tools, and it's a philosophy that helps the organization to build, test, and deploy software at a faster rate and in a more reliable way. So this is the main idea of DevOps. And this DevOps culture is actually going to be implemented with various phases. By looking at this figure, we can see that it's an infinity symbol, right? This DevOps culture is basically divided into 8 phases. Here we are having the plan phase. That means planning is the initial stage or initial phase. Then we'll be having the code phase, build phase, test, release, deploy, operate, then monitor, and again it is going to the plan phase. So it's like an infinity symbol, or we can say that it's a continuous process, right? So what all are the things that is in the plan phase? What all things that we do before writing a code comes under the planning phase. Things like that, we need to collect the requirements and feedbacks from the stakeholders and customers. And this product manager or the project manager is going to create a product roadmap. And this product roadmap can be tracked using any ticket management systems like Jira or Asana or whatever it may be, right? And this product roadmap can be further divided into, say, epics, tasks, user stories, features. There are different terminologies there. We will be having the epics at the top. Then we will be having the features, user stories. Okay, and from this, we will allocate tasks to the developers in each of the sprints. So all these things will be happened in the plan phase. And in the coding phase, the developers are going to start off with the code. But the main idea here is when they are developing the code itself, they need to write the unit test. Then only we can actually perform the continuous integration part. In the coding phase, they will use advanced technologies with the IDs so that these plugins can help the developers, right? And once they develop the code, they are going to raise a pull request, or once they develop the feature, they are going to raise a pull request so that this code will be merged to the main branch that contains the production ready code, right? So during the build phase, this code will be taken from the version control system and the continuous integration server. This server's duty is to actually test the code, right? Test with the unit test cases that is there in the code itself. So all the things will be happen in the build phase. And at the end of this build phase, we will create an artifact. So that is the thing that we are going to deploy into the dev environment or UAT environment or production environment, right? So this output of the build that is the artifact, will be deployed to the dev environment and the QA environment, or it can be the UAT environment. There we will perform some testing. So this test phase is that one. Okay, so this test phase means we are deploying the artifact into development environment, QA or UAT, and there we will perform heavy testing like the load testing or stress testing or the performance testing. All these things will be carried out in this test phase. And after this test phase, we'll be having the release phase. In this release phase, we are ensuring that everything is perfectly okay so that we can release this artifact to the production environment. So in this release phase comprises of those things. Okay, once we are ready with the release, we can directly deploy that to the production environment. So in the deployment stage, we are actually deploying that to the production environment. And once it is done, we will be jumping into the operate phase or the operation phase. In this operation phase, based upon the loads, it will automatically scale the services. All these things will be happening in the operate phase. And also we will provide a mechanism for collecting feedback from the customers or from the users, end users, right? So we will be providing some mechanism for collecting the feedbacks. All these things will be happening in the operate phase. And finally, we'll be having a monitor phase. In this monitor phase, what happened is that we will collect those feedbacks that we obtain from the operation phase. And also along with that, we will collect the performance metrics, then the user behavior statistics. All those things will be monitored in the monitor phase. And this output of the monitor phase is given back to the plan phase. So this process will continue. Okay, this process will be a continuous one. So this is the idea of DevOps. Then why we need DevOps? That is the important question, right? Why we need DevOps? Normally, we'll be having two set of people. One is the developers and other is the operation team, right? And both of them are having different goals. The goal for the developers is the agility. They need to release new features and bug fixes as quickly as possible. Agility is the main focus of developers. While for the operation team, the main goal is the stability. They need to ensure that everything is stable in the production environment. So sometimes what happens is that these both goals is contradicting with each other. So how to resolve those things, right? Operation team needs stability while development team needs agility. Okay, both of them are contradictory, right? So how to resolve those? We can resolve those using DevOps. Okay, so DevOps helps satisfy both of these needs. That is the idea of DevOps. And in normal software development lifecycle, we will be having several bottlenecks. Things like that. Once we give this to the testing team, they can take 2 or 3 weeks for the entire testing. It may delay the process, right? Sometimes we are telling the operation team to deploy the artifact into the production environment or to the UAT environment. At that time, thing like that, if that operation team is not available, again, there is problem. There is some delay, right? So how we can overcome this delay? We can overcome this delay using DevOps approach. So this is the idea of DevOps. So when we look at this particular picture, we can see this. You can see this continuous integration is there, continuous deployment is there, continuous delivery is there, and also continuous feedback is there. So basically, in this figure, continuous integration starts with the coding phase. Okay, so you can see this green color, right? So this green color starts with the coding phase. Once the developer commits the code, what happened? This continuous integration server is going to build that code, and finally, this continuous integration server will perform the unit testing. So all that type of testing will be coming under this build phase. Okay, so code and build comes under the continuous integration. Then if you are following continuous delivery, that means up to the UAT or up to the pre-production server, we are automating everything. If that's the case, I can say one thing: continuous delivery is an extension of continuous integration. That means continuous delivery starts with coding phase, then building, then testing. Testing means once the artifact is created, these artifacts will be deployed to the dev environment, to the pre-production environment. All these things will be going to be automated one. And finally, we are making sure that everything is perfectly right. Okay, so up to release phase, if we are going with an automated way, then we can call it as continuous delivery. And then what is continuous deployment? Whenever we start from the coding phase, it will go through build phase, test phase, release phase, and to deploy phase. If all the things are going in an automated way, we can call this as continuous deployment. And finally, we'll be having another terminology, that is a continuous feedback. Continuous feedback means we know that we need to get the feedback from the customers. Okay, based upon that, we are adding new features to the software. So this is one of the important things that we need to consider. So continuous feedback is one of the most important thing, and that will comprises of operate phase, monitor phase. Once we get all those things, we will be given back to the planning phase. So this is the continuous feedback phase. So here, in other words, I can say like it is continuous everything, right? It's continuous everything. It's an infinity cycle. It's an infinite cycle, right? Okay, so this is the idea of DevOps. Then what all are the tools that we are using in DevOps? So for the scripting part, we may be using the Perl script, Python script, Groovy script, Bash script. It depends upon the project. So there are a lot of scripts available. We can choose whatever scripts that we like based upon the project. And when it comes to the case of CI/CD tools, we may be having Jenkins, Azure DevOps is there, GitLab is providing their own runners, or we can provide self-hosted runners. GitHub is providing the runners. Then TeamCity, Bamboo, Circle CI, all these are CI/CD tools. These help us to build the test cases. Okay, build the software codes, or build the source code, and finally we can perform the testing with these kinds of CI/CD tools. Then we may be using build tools like Maven for Java project, Gradle for Java project, then Apache Ant is there, Buildmaster is there. These tools help us to create the artifacts. Maven will create a jar or war file, depends upon our need, right? So these are basically used for the building purpose. Then for the source code management, for storing the codes, right? We can use Bitbucket, we can use GitHub, Subversion. Then when it comes to the case of Azure, we will be having the Azure repository. When it comes to the case of AWS, we will be having the AWS code commit. There are different type of source code management tools available. And when it comes to the case of deploy tools, we may be having Puppet, Chef, Ansible. That kind of tools are available there. And when it comes to the case of virtualization and containerization, we may be using Docker, Kubernetes, Amazon ECS is there, Microsoft Hyper-V is there, Apache Mesos is there. Okay, lots and lots of tools are there in this DevOps ecosystem. Then coming under the report, statistics, and analytics, we may be using Tableau, Nagios is there, New Relics is there. Okay, so these are some of the tools that comes under the reports, statistics, and analytics part. Then from the point of test automation, we may be using JUnit for the Java unit testing. We may be using PyUnit for the Python unit test cases. Okay, then we can do the integration test using the Postman. JMeter is for the load testings, all kind of things. Okay, there are different type of unit test frameworks, or the integration test frameworks are available with the test automation tool category. Then coming with the static code analysis tool, we may be using SonarQube, Coverity is there, RealSharper is there. Okay, these are some of the tools that comes under the DevOps ecosystem, and each year new tools will comes into the picture, and it may replace the old ones. Okay, so in DevOps, the main challenge is, firstly, we need to understand the core concept of DevOps, and after that, we need to work with these kind of tools. So it is evolving. The tools are evolving, right? So we need to be cope up with these kind of tools. Okay, so this is the idea of the DevOps tools ecosystem. Okay. Then what is the need for security in DevOps, or why we are going with DevSecOps? So basically in DevOps, the main focus is on getting an application to the market as fast as possible. That means we need to release the software as early as possible. And in this DevOps, what happened is that we will do the security testing at the end of the application deployment. That means when we are in the pre-production server, we will do the security testing. And for doing that security testing, we may be having a separate team for that. We may be having a separate security testing team for doing this security testing kind of things, right? So this is enter a separate thing in DevOps, this security, right? So what are the problems that we are facing if we are doing like this, right? So this security checks or the audits right before the release, that means the security audits that is happening in the pre-production server will block the whole process and delay the releases for weeks. So if we are delaying the releases, that means we are creating a bottleneck, right? We are creating the bottleneck. So how we can avoid that bottleneck? And this delaying of security testing increases the risk of security issues. That means if we are not properly testing the application or the product, these issues may slide into the production. And we know that fixing these security issues in the production is much more expensive. So the question is how we can fix the problem or how to solve this bottleneck. We can solve this bottleneck by integrating security into the DevOps workflow. Or in other words, I can say that we can shift the security to the left. So what do you mean by shifting security to the left? In this picture, we can see that we are having several phases like analysis, design, implementation, testing, deployment, maintenance. These are the phases that comes under the software development lifecycle, or in other words, we can call it as SDLC, right? And when we look at this, we can say that normally in traditional security model, majority of the security testing is happening at the end of these phases, like the testing, deployment, and maintenance, right? So it may be too late to start at that point of time. So in DevSecOps, what we are going to do is we are going to move this security from the right to the left. That means from the analysis part itself, we will think of security or we will do some security testing. So that is the main idea of DevSecOps. I will call DevSecOps like whenever we apply DevOps culture to the security field, we call it as DevSecOps. Okay, DevSecOps means whenever we are applying DevOps principle to security, we call it as DevSecOps. So shifting security to the left is the process of checking vulnerabilities in the earlier stages of software development lifecycle. So this is the idea of DevSecOps. So this DevSecOps stands for development, security, and operations. In DevOps, we are only concerning about the two teams, that is the development and the operations. But in DevSecOps, we are concerning about three teams: development, security, and operations. And this DevSecOps is an extension of the DevOps practice. You can see that. You can see this for every phases, we are including the security, right? For every phases in this DevOps, we are including the security. So that is the main idea behind DevSecOps. So what is DevSecOps? So it's a practice of integrating security testing at every stages of the software development process. And in DevOps, what happened is that I already told you that we may be having a separate security team, and they are performing the manual testing. They are performing the manual testing, right? They may be using automated test. Okay, that's fine. But majority of the testing will be a manual one. So in DevSecOps, this manual work of security engineers will be automated. And this security test will be included in the pipelines. So whenever we run a pipeline, automatically this security test will be happen there. And if there is a failure, it will break the pipeline at that point. So that is the idea of DevSecOps. So it's basically a cultural transformation that makes security a shared responsibility for every team. Like it's the responsibility of developers, it's the responsibility of security team, it's the responsibility of the operation team, right? And you may be asking, then what is the why we need security team? So security team act as a facilitator. They will help the development team. So like these are the problems that we need to focus on at the time. this development team get an idea regarding what all are the things that we need to perform. You know that there are different type of security attacks are there, like cross-site scripting, SQL injection is there, phishing is there. Okay, so how we can overcome these kind of attacks using DevSecOps? That is the main idea. So when it comes to the case of DevSecOps tools, or in this ecosystem, we are having different categories. One category is the secret scanning. So basically, what is the purpose of secret scanning? Think like that, if a junior developer accidentally puts some secrets in the source code, if that's the case, this secret scanning tool is able to find out that secrets. Okay, so thereby we can ensure that, okay, these secrets are exposed. So how to resolve those? Okay, again, one thing is that before including the secret scanning tools in the pipeline, this needs to be start in the developer's workstation. That means whenever we are working with the IDEs, integrated development environments, we need to use different plugins. So we can use pre-commit hooks. There are different secret scanning tools like Git leaks, Git secrets, truffle hog. These are some of the secret scanning tools. Okay, so the idea behind is whenever the developer is trying to commit a code, at the time itself, this Git leaks or Git secret or the truffle hog will scan the source code, and if the source code contains any secret, it will prevent you from committing the code itself. That's why we call it as pre-commit. Okay, pre-commit hooks. We can set up those things. And thing like that, if the developer is not using these pre-commit hooks, then what happened? We know that by committing, this secret will be exposed. This secret will be directly jump into the source control systems, right? It will be there in the GitHub, or it will be there in the Bitbucket, or whatever it may be, right? So once the secret is there, it will be maintained in the history. So at that time, it will be very difficult to edit the history. So the only option that we are having is we can regenerate the secrets. Okay, we can regenerate the new secrets. So that is the idea there. So it is better to use this secret scanning tools from the development workstation as a pre-commit hook. Then in the pipeline also, we will be using these secret scanning tools. So this is the idea of secret scanning. Then another category is the software composition analysis. In short, we can call it as SCA. In our code base, you may be using different libraries, or you may be using different frameworks or packages. If your code is perfectly right, that means your code does not contain any vulnerabilities. But think like that, if you're using a library or framework in your code, and if that library or framework contains a vulnerability, then your entire source code becomes vulnerable, right? So in that case, we need to actually scan the libraries or scan the frameworks or packages that we are going to be used in our project, right? So for that, we can use software composition analysis tools. Some of the tools can be the OWASP dependency check or JFrog X-ray. GitLab is having their own SCA tools. Okay, we can integrate these tools in our pipeline. So thereby, we can make sure that whether these frameworks are vulnerable or not. If they are vulnerable, then we need to take precautions. Think like that, if you are using an outdated version, and if that outdated version of that particular library is vulnerable, then we need to upgrade that library, right, to the higher version. At the same time, we need to check that our source code will not break, right? So these are the things that we need to consider there. So software composition analysis is based, can be used for that particular purpose. Then we'll be having the static application security testing. In short, we can call it as SaaS tools. So SaaS tools is a type of white box testing. White box testing means this SaaS tools is going to analyze our source code. It is going to analyze our source code for the non-security vulnerabilities. In every project, we need to make sure that we are performing the code quality checks. This code quality checks contains different aspects, like we need to check the code duplication, whether the code is duplicated at several points. If that's the case, it's not a good style, right? So we need to identify the code duplication. Then we need to do the we need to figure out where there is any bugs out there in your source code. Okay, so these kind of things needs to be done. So this can be done using the static application security testing. In short, we can call it as SAST, and this is performing on our source code. So there are different categories. There are different examples for the SAST tools. One is the checkmark. SonarQube is there. SonarQube can actually perform the SAST on different programming languages. Then GitLab is having their own SAST tools. Okay, then there are some SAST tools specific to programming languages. You can check it out. Okay, based upon our need, we can use different SAST tools in a pipeline. Okay, in order to ensure more security. So these kind of tools can be used in our pipeline. The next category is the vulnerability management tools. So why we need vulnerability management tools? Think like that in our secret scanning tools or in our SCA tools or in our SAST tools, they all are generating a report, right? We need to go through the logs that is created by these tools. So rather than going through these logs, all the output from these tools can be sent to a centralized UI. Or in other words, we can say that vulnerability management tool gives you a unified view of the security weakness that is identified by various vulnerability scanners, like the secret scanning tools, or it can be the SCA, or it can be the SAST tools. Okay, so some of the examples of vulnerability management tools are Defect Dojo, then Archery is there, Hackety is there. Okay, these are some of the categories that comes on. These are some of the tools that comes under the vulnerability management tools. Then IAC scanning is there. So what do you mean by IAC? IAC means infrastructure as a code. You are not going to manually create the infrastructure in Azure or in AWS. Instead of that, nowadays we are writing infrastructure as a code. That means with the Terraform is one of the tools. Then we'll be having the CloudFormation, Pulumi is there. Okay, with these tools, we can create the infrastructure by specifying in the code. Okay, we will write the code for that. And when we run that code, it will automatically create the infra for you. Thereby, we can ensure that in every environment, the entire service is same. Okay, so for that, IAC will be having some security scanning tools. That is the IAC scanning tools. And think of that, like this, we may be having a Docker file for creating a Docker image. Okay, so again, for those kind of things also, we need to scan for the security vulnerabilities, right? We can do all those things with the IAC scanning tools. So basically, Aquatree is there, Sync is there, Chekhov is there. When it comes to the case of Terraform, we may be having the DevSecOps is there. Okay, TerraScan is there. These are some of the tools that can be used for the security checks in the IAC code. Okay. Then coming to the next category, that is the dynamic application security testing. We learned about the static application security testing, but here the name is dynamic application security testing, or in short, we can call it as DAST. So DAST is a type of black box testing. That means it is not going to analyze your code. Instead of that, it is going to do the security testing on the running application. Okay, whenever our application is running, it will do the security testing. So it is like an hacker attacking the software. It is the same behavior. Okay, it is going to simulate that particular behavior. So we are directly going to give some attacks using the software in order to know that whether our software is vulnerable, right? There are different type of attacks, like the passive attacks, active attacks. Passive attacks means it will give you the reports. These are the attacks that can be done in your software. But if you're following an active attack, then it will directly attack your software. It may alter the resources. Okay. Some of the tools for the DAST is SAP. GitLab is providing their own DAST tools. Checkmark is providing the DAST tools. Okay. In SAP, we are having the active attacks, passive attacks. We can do all kind of things using these tools. Okay. So this is the dynamic application security testing, or in other words, we can call it as DAST tools. Then we'll be having the secret management. So how we can store the secrets? So we cannot store the secrets directly in the, or we cannot directly put the secrets in the source code, right? It's not a good practice. So how we can store the secrets? We can store the secrets using the secrets management tools. Some of the examples of secret management tools are Azure Key Vault is there, AWS Secret Manager is there, HashiCorp Vault is there. GitHub is providing their own secret management tools. GitLab is providing their own secret management tools. In this with these secret management tools, we are going to store the secrets. And whenever the code needs to access those secrets, it is going to use this secret management for fetching out the secrets from there. Thereby, we can improve the security. These are some of the DevSecOps tools categories that we are using in our organization. And based upon your organization, you can increase the security. There are lots of categories available, but these are the main categories that we need to focus on. Next, I will show you a demonstration. So in this demonstration, I tried to include various DevSecOps tools. So let me directly show you that. So let me share my entire screen. Whether my screen is visible to all of you? Can I get a quick confirmation?
Yes, Nithin.
Okay, thanks for that. So this is my Azure account. And in this Azure account, I'm running a virtual machine. You can see here, it's a DevSecOps. The name of the virtual machine is DevSecOps, right? So I can see the public IP here. So I'm going to copy this public IP and pasting that in the portal. So this is an image classifier. This is a machine learning project. Okay, this is a machine learning project. The idea of the project is whenever we are giving an image to this software, it will tell you what exactly that image is. If you're giving the image of a cat, it will tell you that it's a cat. If you're giving the image of a ship, it will tell you that it's a ship. Okay, so this is the idea of this particular software. So let me show you that. Let me give the image of a cat and let me submit that. It will tell you that it's a cat. Okay, so let me clear this one and give another one. This is the image of a ship. Okay, you can see this. This is the image of a ship. Let me give this one and submit this. This you can see the result here. It's a ship, right? So how we are actually deploying this particular application? So this VM is actually running a Docker image. Okay, this VM is actually running a Docker image. And the entire code of this application can be found here. Okay, you can see my repository here. There is a project called image classification. And for the CI/CD part, here I'm using the GitHub Actions. Okay, for the CI/CD part, here I'm going to use the GitHub Actions. So inside the repository, there is one folder called as .github/workflows. Let me go into that. Okay, let me go into that. And when I open this particular YAML file, I named it as pipeline.yaml. Okay, so you can see this YAML file. So here, I have created a pipeline. And in this pipeline, I am stating that whenever there is a push or pull request trigger on the main branch, I need to activate this pipeline. I need to activate this pipeline. And in GitHub Actions, you will be using different jobs. Okay, different jobs. And in this, I'm having a security scan job. You can see this security scan job, right? And I'm giving a name for this particular job. And this is going to run on a specific runner. Okay, that is provided by the GitHub itself. This is an Ubuntu mission. Okay, then what all are the things I need to do that in the job, do in this particular job? In jobs, you may be having different steps, right? You may be having different steps. First thing is that whenever I commit a particular thing into the code repository, it needs to check out that repository. And after that, I need to run the git leaks. So what is the purpose of git leaks? I need to check that is there any secrets present in the code? If there are some secrets, then this git leaks is going to detect that and it is going to break the entire pipeline. So here, the first tool, that is the secret scanning tool, is used here. That is the git leaks. And if everything is perfectly right, for example, thing like that, no secrets are there in the source code, then it will return a success. And after that, I'm going to set up a Python environment. So basically, this is a Flask application. Okay, so this is a Flask application. And for that, I need to set up a Python environment, right? And for that Python environment, I'm specifying that which is the version of the Python I need to use here. I'm saying that I need to use 3.11 as the Python version. Okay, so these are the actions that you can directly use from there, right? So this is the setting up of the Python environment. And once I done that, I need to perform the SAST operation. That means static application security testing. That means whatever I wrote in that particular thing or whatever code that I have written, I need to cross check that whether or is there any security vulnerability present in that particular code, right? So I can perform the SAST using Bandit. Bandit is one of the tools that you can use. Bandit is specifically designed for the Python language. Okay, so I'm going to install the Bandit package and finally I'm going to run that Bandit, and this is the source folder location where my code is there. Okay, so it is going to analyze my code for vulnerability. Is there any vulnerability or not? It is going to analyze those things there. Then I'm using a pip audit. It's not a completely SEA tool, but still this pip audit package can be used to analyze the packages that you're using in your code. If your code contains some of the libraries, it is going to scan those libraries to check for the vulnerabilities. And normally we can install this pip audit using the pip command. Then after that, I am running this pip audit on the requirement.txt. So what is that requirement.txt? In this project, I'm having a separate file called requirement.txt. You can find that here in the left side. So in this requirement.txt, I'm having a Flask, then NumPy is there, Pillow package is there, Gunicon is there, OpenCV Python headless is there. These are some of the packages that I'm using, right? So it is going to check these libraries, and if there is any vulnerability, it will display that and it will abort the pipeline. Okay, so that is the idea there. Then going back here, then we'll be having, so once it is done, if everything is done, I need to create, okay, thing like that. SAST is perfectly okay. SCA tools are perfectly okay. Secret scanning is perfectly okay. If that's the case, I need to create a Docker image for this application. So by creating a Docker image, we are actually packaging everything, our libraries, our application source code, all those things will be packaged in a Docker image. So for that, I am using another job, build, scan and push image. That is the name of this particular job, right? So it is going to run on this hosted agent, that is the Ubuntu latest, with the Ubuntu latest with the Ubuntu operating system. Then it will run only when a direct push is happened to this main branch, or it can be a pull request, but we need to merge that pull request. Then only it will run this particular job. If you are opening a pull request, then this job will not work. Okay, or if you're directly pushing the code then to the main branch, this job will work. That is the condition giving here. And inside this, again, inside this particular job, I'm again checking out the repository. I'm going to create a Docker image based on a Docker file. So I have written the Docker file here. You can see the Docker file here. So that contains the instructions for creating a Docker image by using Python 3.11 Slim as the base image for that. And I'm specifying the instructions for creating the Docker image. Okay, all these things are written in the Docker file. So based upon that, it is going to create a Docker image. Once it creates a Docker image, we need to actually test the Docker image for the vulnerability. test the Docker image for the vulnerability. For that, I use the Trivy scanner. Okay, so this is a IAC scanning tool. So with this IAC scanning tool, I'm going to detect the critical and high vulnerabilities. And if that's the case, it is going to exit the code with 1. That means it needs to abort the pipeline. Okay, and here you can see this vulnerability type OS and library. OS and library means it is going to check the Docker images for the OS layers and also for our application code, right? If we are keeping only the OS part, then it will check only the OS layers of that Docker image. It is not going to check for the application code in that Docker image. We can customize this according to our needs. Okay. Then if everything is successful, this image will be directly sent to the Docker Hub. Okay. This is the instructions for that. And finally, we'll be having another job, that is the deploy job, where we are going to enter into this particular VM, that is DevSecOps, this virtual machine, and we are going to deploy this image into that particular VM. So that is done using these steps. Okay, once it is deployed, we need to perform the DAST operation, that is the dynamic application security testing. So here I am running a SAP scan. This is a passive attack scan, because you can see this. I am using a baseline.py that contains only the passive type of attacks. If you're doing active attacks, then it will take more time. Okay, so these are the things that I'm doing here. So let me run this application once again. So how to run this? Basically, for this Flask application, you can see the static folder. Inside this, you will be having the CSS and the JavaScript files. Inside the templates, you will be having the HTML files. So HTML is the skeleton for the website, and CSS gives you the beautification for that website, and JavaScript gives you the interactivity, right? So those things are there in the static and the template folder. And apart from that, I am having a app.py file. This contains the Flask code. So this is written in Python, right? And again, it is going to use a model that is created by me. That is the cipher.onyx model that I've created earlier. And this app.py is going to load this Onyx model using the OpenCV library. I'm not going to the depth of those things because it's not an AI session, right? So just get the concepts well. And here, what I'm going to do is, let me change one of the thing here. So you can see this by looking at this application, you can see the tab here. What is the name given in this tab? Image classifier. You can see at the top. I'm not telling about this name. I'm telling about the name that we are seeing in this tab, right? That is the image classifier. So this is given here. So let me directly change this. Don't do that. For the simplicity, I'm directly going to edit these things from the GitHub itself. So let me edit this and put like image classifier. Instead of image classifier, I'm going to give it as demo. Okay, give it as demo. And let me commit the changes here directly. So this is a direct push. When this happens, you can see this change here. You can see a small circle brown color here, right? So when you click this, you can see the pipeline gets triggered and you can see the details here. So when you click this, you can see this. It is setting up the Python environment. You can see this running git leaks. So when we expand this, I can see that this is the output of the git leaks. Here you can see this no leaks found. That means this code does not contain any secrets. Okay, this is the git leaks running. And then after that, pip audit is running on my packages that I'm using in my application. So here you can see this. After checking all the packages used in my application, it is saying that no vulnerability is found. It's perfectly right, right? It's perfectly right. And after that, let me directly go to the build, scan, and push Docker image. So this is the next job. You can see the procedures here. You can see the Privy installation, that is for the IAC scanning. So I'm checking out the repository. I'm building the Docker image. So once we build the Docker image using the Docker file, we need to run the IAC scanning, right? that is happening here. Run Trivy vulnerability scanner, and you can see this. You can see this. There are no high or critical vulnerabilities. You can see this. There are no high or critical vulnerabilities because in this particular scenario, I am only scanning the OS part. And again, after that, if everything is okay, we are going to push that image to the Docker Hub. So I'm having a Docker Hub. You can see this one. This is my account. And let me refresh this one. Let me refresh this one. And you can see this Nithin PJ09/classifier. Last pushed less than a minute ago. So this is the image pushed to the Docker Hub, right? Once I've done into that, then I need to deploy this image into the virtual machines. So here you can see the deploy job. So at this time, this pipeline is going to enter into the virtual machine that is hosted in Azure. Okay. And there it is going to remove the already existing Docker image and replace with the new images. It is done here. And once it is deployed, I'm doing a SAPS scan. That is the DAST tool, right? That is one of the DAST tool that we are going to use here. So when we are running the DAST tool, it is going to download the SAP container for that. And once it is done, so let me check what happened using the automation. It is now checking. It is checking for the passive attacks, right? So let me run these things. You can see this, all these tests are passed. Okay, these are the kind of things that is performing in the SAP baseline scan. And I'm getting some warnings, right? I'm getting some warnings. These are the warnings, but I don't have any fail or ignore or kind of things. Okay, pass 60%, 60%, 60 tests are performed, not 60%, 60 tests are performed. And here you can see this, all the tests are passed. Okay, and when I refresh this particular thing, okay, let me go here. Okay, so one thing, so I have changed that particular, so not the tab, I have changed, let me tell you again. So instead of this image classifier, I replace that with the demo. Not this one, this one. Okay, I have not edited that title. Instead of title, I have modified, sorry for that. I have modified that. I will show you where we need to change. Let me go to this templates. Let me go to the index.html. Okay. So you can see the demo is changed. This is going to be present here. Okay, this is going to be present here. So this is the idea. This is the idea that I need to showcase. And along with that, one more change I need to perform. Let me close this one. Let me close this one, and let me directly go to the workflows. Instead of running Trivy on OS layers, I need to run that on library also. Okay, so then what will be the result? So let me edit this one. Let me edit this pipeline. Instead of say this one, okay, right? This vulnerability type OS, I'm going to comment it out. Instead of that, I need to run both I need to check both for OS and library. So let me commit the change. Okay, let me commit the change here. And when I run this, what will happen? So let's check. Again, these things are happening there. Git leaks, everything is working perfectly. So now time is around 9, right? So I will stop, or I will wind up within 5 minutes. So during the build, scan, and push the Docker image, we need to check what happened. So it is actually building the image, and now we are performing the IAC scanning. Now it will break the pipeline. Why? Look at this. There is one library called setup tools with the installed version of 65.5.1 that is having a vulnerability. So this is the vulnerability ID that we are getting here. So you can directly check it out. What is that vulnerability? So here you can see this vulnerability in the package. Okay, or you can go there, or you can see this in the advisory. Okay, so there is one vulnerability. This vulnerability in the package index module of PYPA setup tools version up to 69.1.1 allow for remote code execution via its download function. So this is one of the vulnerability. But think like that, this library is not used in my application. From where it came, right? Or from where it came. So let me go back to the image classification, or let me directly go to the Docker file. And in the Docker file, I can see that I have used one base image, Python 3.11 Slim, right? So let me go to the Docker Hub and search for Python, that specific version. Python, let me go to the official repository of Python. So here you can see the various versions of this Python Docker image. Okay, and out of that, I have used, you can see this 3.11.9. I've used this 3.11 this one, 3.11 hyphen slim. So when I click this, you can see that here. You can see that in that particular base image, they used the 65.5.1 version for this Python setup tools. Okay, so that's why our entire application becomes vulnerable. So how to resolve that? We can resolve that by using another version of Python base image, or we can set up our own base image. Thereby, we can resolve this vulnerability. So this is the way we need to identify the vulnerabilities, and also we need to, again, whenever we identify the vulnerabilities, we need to fix that. Okay, we need to fix that. So this is the way we need to fix that. So another example, let me show you another example. Let me go to the actions. I will show you one more thing. Earlier, when I ran this one, I got a particular error. So in the run security scans, this is the older one, right? In run security scans, in the pip audit, I'm getting an error. Unicorn 21.2.0. This contains a vulnerability, right? So how to fix that? We can fix that using the newer version, that is 22.0.0. So for that, I've changed the requirement.txt to that new version. So in the requirement.txt, you can see this in the requirement.txt. You can see this in the unicorn. I specified the version as 22.0.0. So thereby we can avoid that vulnerability. So this is the idea regarding DevSecOps, how we can incorporate DevSecOps tools in our pipeline, how we can enforce security by incorporating security tools at every stages of the application development. So with this webinar, I hope that you got a clear understanding about what exactly CI/CD is, what is DevOps, and why we need DevSecOps. Okay, so thanks for listening, and you can find me on LinkedIn. And if you are having any queries, you can post that. You can connect with me. I am very much happy to share the answers with you. Okay, so that's all for today's webinar. Thanks for listening.